So 3.4c is about function composition. So yesterday we had talked about function operations. So adding, subtracting, multiplying, dividing functions. The main thing that you want to take away from this is the fact that this notation here, if you see that open circle notation means composition. So you always want to take and rewrite it. So where the open circle is, you want to take it out and you would have put a parenthesis with the G inside of the F. So this means we're going to put the G inside of the F. We're going to put the G inside of the F. So that open circle means composition, not multiplication. Multiplication will be a closed in and just a little dot. Function composition will be an open circle, okay? So the first, although they haven't asked us to do this, I would like to do the following. Let's say that we have, that is an S, yeah, can't you tell? If they have S of t, that really means we're going to take the S function and we're going to plug t into it, okay? That means we're going to take the S function and we're going to plug t into it. So I just want to practice doing that. We're going to use the functions that we see right here for S and t. So our t function, what you're going to do is you're going to write your t function inside of your S function. So I'm just going to write out the t function. It's negative x plus 1. And then that's going to be my input into my S function. So if we look at my S function down here, it's negative x plus 2. So it's really just the opposite of my input plus 2. But my input happens to be negative x plus 1. So because of that, what you're going to do is just simplify as much as you can. You can't do a whole heck of a lot. That negative that's outside the parentheses, we can distribute to give us x minus 1 plus 2, or S of t is x plus 1. Now, that is if there wasn't an actual numerical input that they have mentioned. But let's look at what they ask us to find. They ask us to find S of t of 3. So I'm going to write that a little bigger over here on the side. Now, S of t of 3, you want to work yourself from the inside out. So whatever it is directly next to means I am going to plug 3 into the t, and then I'm going to plug that answer into S. So work your way from the inside out. So if I plug 3 into my t, the t says to take the opposite of that plus 1. So that's just going to be the opposite of our input plus 1. Now I'm ignoring that the S is even there. I'm only using the t function, and I get an answer of negative 2. Now I'm going to put that negative 2 into my S function. So here's my S function over here. It says the opposite of that plus 2. Well, the opposite of negative 2 is positive 2. Plus 2 is 4. But think about if we found S of t of x up here, it was x plus 1. If you plug in 3, you get 3 plus 1, or 4. So you can do the generic version, leave the x's in there, and then plug your 3 in. That's one option. Or you can plug 3 into the next most function, get a value, plug that value into your next function. So work your way from the inside out. Work your way from the inside out. Okay. So now let's look at these ones. So the first one they've asked us to find is Q of P of 2. Okay. Now, anytime you see that notation, we're going to replace that open circle with a parenthesis, a start of a parenthesis. So I'm going to write that as Q of, that's not a Q, Q of P of 2. So just take out that circle and put a parenthesis there. That's your start of your parenthesis, okay? So now what we're going to do is we're going to plug 2 into the closest function. So the closest function is P. So we're going to put 2 in here. Now you can do that sometimes in your head. 2 squared is 4. 4 plus 5 is 9. So that's just Q of 9. Now we have used the P function, so we're done with it. We plugged 2 into the P function, we got 9. Now we're going to plug 9 into the Q function. So if I plug 9 into my Q function, I get the square root of my input plus 7. Well, 9 plus 7 is 16. The square root of 16 is 4. So Q of P of 2 is 4. Okay. Now be careful, because the next thing they asked us to find was P of Q of 2. When they ask us to find P of Q of 2, remember, we are going to take the P function and we are going to input Q of 2. Because now we put 2 into the Q function, get that answer, plug it into the P. If we plug into the Q function 2, it's going to go right here. The square root of 2 plus 7 is the square root of 9, or 3. Only once you have that simplified down as much as possible, now we input that value into the next function. So this is going to go into our P function. If I plug 3 over here into the P function, I'm going to get 3 squared plus 5, or 9 plus 5, which is 14. So you get very distinct things most of the time, because when you start with one function, you're going to get to that one first, and so you might get a totally different answer if they switch this around. Expect that you'll get different answers both times. Any questions about those ones? Okay. Now, let's talk about this notation. Now, I know they didn't ask it, but the first thing I want to find is g of x. Not g of x, I'm sorry, g of h of x. So I want to just practice finding g of h, just so you can see what the compositions mean. Now, g of h means, remember, we're going to take the g function and we're going to plug in h of x. We're going to take the g function and we're going to plug in h of x. What is h of x? H of x is x minus 2. So just replace it in there. That's g of x over 2. So we've been practicing doing functions, and to input into a function, you just take out the original x and you put in whatever's inside. So we're going to take out the original x and we're going to put in whatever's inside. And so our answer is going to be, I'm going to go this way, I know that's weird, but it's going to be that thing squared, take away 8. Well, the input is x over 2, the h function. Now you can't do much with it. You could possibly make it x squared over 4. To square a fraction, just square the top and bottom. So this final answer would be x squared over 4 minus 8. Okay. Now, look at what they've asked us to find down below. They wanted us to find g of g and h of h. To square a fraction, just square the top and square the bottom. Okay. So yeah, just do them each individually. Okay. So now I want to find g of g. Now, what does that mean? Well, that means we're going to take the g function and we're going to plug g into it. That's what that notation means. In g of g, we're going to take the g function and we're going to put it into itself. Now, what I do is so that I'm not going to hopefully confuse myself, is I will actually just, that inner g, I'll write down what g is. G is x squared minus 8. And now that's just the input. How do you input something into a function? You take out its original x and you replace it with whatever's inside. So we're going to just replace it with x squared minus 8. So what you get is you get the x squared minus 8 is that input squared minus 8. And that's where you put the other x squared minus 8. Okay, so let me show you one more time. This is the g function. The g function is x squared minus 8. It is going to be inputted into g. And so we take out the original x and we replace it with whatever the input is. It just happens to be the same thing, gets inputted into itself. So when you have g of g, you're inputting the original into itself where the original x was sitting. That's weird, but now remember, x squared minus 8 squared is really x squared minus 8 times x squared minus 8. So if you have to write that down somewhere along the side to do that multiplication correctly, do it. Now let's talk about that multiplication. X squared minus 8 times x squared minus 8 is going to be x to the 4th. You're going to get a minus 8x squared and a minus 8x squared for a total of a minus 16x squared. And the negative 8 is plus 64. But then you do have that minus 8 on the end. Don't forget, you still have it. We are squaring our input and taking away 8. Squaring our input and taking away 8. And then when you combine it, the answer will be x to the 4th minus 16x squared plus 56. Okay, so that is g of x. Take this notation and rewrite it with parentheses, and this thing is being inputted into the other. This thing, the thing after the open circle, is being inputted into the other. Everybody okay with that one? They're strange. Okay. The next one they asked us to find was h of h. Okay. So rewrite that notation to say h of x. Rewrite that notation to say h of x. Where this inside stuff is sitting, we know what h of x is. Down here, it told me that h of x is x over 2. So where this is sitting, I know what that is. That's x over 2. I'm going to take it out. I'm going to put x minus x over 2 in its spot. So let's take it out. And let's put x over 2 in its spot. Now we can ignore that other stuff and go, how do I input x over 2 into the h function? Yes.
Put x over 2 over
2. Exactly. So we're going to put that input over 2. Now, how do you do that? Well, to divide by 2 is the same as multiplying by a half. Divide by 2 is the same as multiplying by a half. You can make this even like 2 over 1 and do my big C over little c trick. It will multiply it by a half. To divide by 2 is the same as multiplying by a half. So our final answer is going to be x over 4. Okay, so you have to watch the order after the dot. Whatever's after the dot, that thing is being inputted into the thing that came first. Whatever's after the dot, that thing is being inputted into whatever comes first. That thing is being inputted into whatever comes first. Does that make sense how that works? It's a little weird. Okay, so that's those ones. And then one last one, and then we are going to do a few of the homework problems with together, okay? Now, in this last example, it says find two functions f of g such that when we compose them, we get the function that's there. So all you have to think about, this is what I think about when I do a problem like this. This one is stuck inside. I'm so sorry, my Apple Pencil has broken, so my handwriting's worse than normal even. We're stuck inside the f function. So just ask yourself, what the heck is stuck inside? So what's stuck inside of the cube root? What's stuck inside of the cubed root? 4x minus 2. So we're going to make g the function 4x minus 2. That should be your inside stuff. I'm a little lost. I'll show you in a second. The f function is the outer function. So it's the cube root. Okay, so the f, because f came on the outside, that came first, that's your outer function. G is the thing that's stuck inside of it. This is what's stuck inside of it. And how do you check that you're right? Well, all you got to do is say, if I took f of x and stuck g inside, would I get h of x? So let's check to see if that's true. Well, if I took the f function and stuck in 4x minus 2, that is just taking and sticking into a cube root 4x minus 2. Isn't that exactly what we were trying to make happen? So it's called a decomposition, and this is a concept very much that you would see in a calculus class. There's a thing called a chain rule. There's a thing called a it's a substitution rule, and if you can understand that concept, they're just getting you ready thinking toward a calculus class. So you're really just asking yourself, if we want H to be a composition of two things, the inside thing should be the thing that comes on the right side of your open circle, and then this should be the function on the outside of your thing you stuck inside. So this is the outside function. This is what I stuck inside. Here's your outside function. This is what I stuck inside. Okay, so it's just a matter of what was on the inside, what was on the outside. Kind of makes sense a little bit? Okay, so you're just undoing a composition. What's in the inside, that's your G. What's the outside function? If it was simpler, that's your F. Okay. Last thing before we do some homework together. I forgot about this one. Let's talk about this. It says, here, let's kind of, I'll scooch in and then I'll scooch out again. Okay, so it says we've got these two functions pictured below. This one is our G function. This one is our F function. It says find the domain and range of f of G. Now remember that f of G means that we are starting with an x value in G, we are getting a y value, and we're taking that into F. Okay, so let me say that again. We are starting with the x's in G. We're thinking of them as an ordered pair, and then we are sticking those into F. Okay, so let's go over to G. This is your starting place. If we look at the G, okay, if I start at 0, it connects to 8. So that is the ordered pair 0, 8. Then I take the 8 and I go over to F. Is there something to connect it to? Is there an 8 right here? No, see, there's not an 8. Okay, so that points out. That one won't work. Okay, let's start with the next one. The next x value we're going to start with is 1. 1 connects to 4. So that's the point 1, 4. Okay, so I'm starting with the x's in G. They're going to become the y's, or the G of x's. And then I'm going to take those and put them in the F for them to become F of x's. Okay, so I started with 1. It becomes a 4. I'm going to take that 4 and I'm going to connect it over an F, and what's it become? An 8. Okay, so let me kind of map it out for you. I stuck a 1 in our G function. It became a 4. That 4 in my F function became an 8. So that means that the point 1, 8 is in the composition. I started with 1. Eventually, I get to 8. Okay. So we left off with 1. The next one we're going to check is 2. So I start with 2. It becomes a 2. Then I connect over here, and that 2 becomes an 8. So I start with 2. It became a 2. It stayed a 2. That 2 then becomes an 8. That's the point 2, 8. Okay, let's do it again. Next one I'm going to check is the number 3. I start with 3. It becomes a 0. It has a connection. That 0 becomes an 8. So I started with 3. It became a 0. That 0 becomes an 8. That is the point 3, 8. We just have one more to check. 8. If I start with 8, it becomes a 2. That 2 becomes an 8. I love how everything's becoming an 8. So I started with 8, became a 2. That 2 became an 8. That's the point 8, 8. Okay. So everybody seeing how I connected those things together. You always start with the thing inside. You always start with the thing inside. Okay. Next. Now, what is the domain? The domain of f of g are all the x's that we started with that worked. So 1, 2, 3, 8. So 1, 2, 3, 8. All of the y's we got out, it's just the number 8. So it's just an 8. Okay. So that is how we find all of the paths from G to F. We just kept connecting over here. This kept connecting to 8. Yeah, it just connected. So like we went 3, we got 0, but 0 went to 8. 8 became 2, but 2 went to 8. So we just kept getting 8. Okay. So now let's do this one. So we're going to start with 2 in the G function. Then we're going to connect it to the F function. Whatever we get, we get. Okay. So we're going to start with 2 at our G function. We're going to get 2. We're going to connect it over to our F function, and the F function is going to be 8. So that answer is 8. Let's do this one. This time we're starting in the F function. So we're going to put 2 in the F function. We get 8. We bring 8 over to the G function. It connects to 2. So the answer is 2. For E, what function do we start with? G, right? Okay, so we're going to start with the one that's closest. You always start from the inside out, okay? So we're going to start with 3 in our G function. It becomes a 0. When we connect 0 to our F function, what's it become? 8, our good old 8. Let's do it again. If we stick 3 into our F function, we start at 3 in our F function. See how there is no 3 in our F function? So that is an undefined place to start. So you just say undefined. Now this one, if we put 3 into our G function, so we're starting at 3 in our G function, it becomes a 0. But we're going to use our G function again. So 3 becomes 0. What does 0 become? 8. See, right? 3 becomes 0. Take it over here now. 0 becomes 8. So our answer for that one is 8. Okay. So I'm going to do a few of the homework problems with you just to make sure that we're on the right track, okay? So if you could at this time scroll to your homework. Before I leave this page, any questions? Okay, so let's go down to our functions here. So the first 6 at the top of the page, well, the first 4, you are just plugging in A into the G function, and then that answer goes back into the G function. There are some up on the board if you want to look at those. 9 and 10, you're plugging in numbers. 3 goes into the F function, get a number, that goes into that. So I would suggest before you start any of these, rewrite the notation. So I would write this as G of H of N. For 3, I would rewrite that as G of A. So then you can clearly see what your input is, okay? So that when you put G into itself. Uh-huh. No, once you input it, just simplify it as much as you can and stop. And then 9, that is G of F of 3, okay? But I would like to do one of the ones down from the table. Can we please do this one? So this is your G function. You know, that's just the ordered pair 2, 3, the ordered pair 7, 4, the ordered pair 1, 9. Here's my F function. That's the pair 9, 6, 4, -3, 6, or 6, 7. Okay, let's do A and E. Okay, so let's look at A. What function do we start with? G. So we're going to find the X in G. The X of 2 in G becomes a 3. And then we're going to connect it to F. What does 3 become? The answer is 9. Okay, now let's look at E. What do we start with? This time we start with 6. Which function do we start with? We start with the F function, right? So 6 in the F function becomes 7. And now we stick that 7 into our G function. What does it become? 4. So the answer is 4. Everybody see how I use the tables to get those answers? Okay, so you have time in class now to work on this. Problem 1, 2, and 3 is up on the board if you would like to look at that. There you go.